This video is about covalent structures. The question asks us to determine the electron domain geometry, the molecular geometry, and the bond angle for H3O+. To determine this, we need to use the VSEPR theory. The VSEPR theory stands for valence shell electron pair repulsion theory. It is used to determine the 3D structure of a molecule by using its 2D Lewis structure. Hence, we need to find the Lewis structure to begin. We see that H3O+ consists of one oxygen atom bonded to 3 hydrogen atoms. However, we do not know if this satisfies the complete Lewis structure, as there may be lone pairs of electrons present. Hence, to determine this, we can use section 6 of the data booklet, which is the periodic table. Using the periodic table, we can look at the group number to determine the number of valence electrons present. So, hydrogen has 1 valence electron, and oxygen has 6 valence electrons, as it's in group 16. However, as there is 3 hydrogen, we times that value by 3, which gives us 3, and there's only 1 oxygen atom, so we just leave it at 6. When we add those two values together, that gives us a total of 9 valence electrons present. However, make sure to consider if there is a positive or negative charge in the molecule. We can see that this molecule has a positive charge, which means that the molecule has lost an electron, as electrons consist of a negative charge. Therefore, we minus 1 from the amount of valence electrons, which gives us a total of 8. Within the Lewis structure, each bond consists of 2 electrons. See, we have 2, 4, 6 electrons present. However, our calculations gave us 8, meaning that we're missing 2 electrons, which therefore is accounted by a lone pair of electrons. To get a clearer picture of the 3D structure, we can draw the Lewis structure like this, which represents a hydrogen being in the front, a hydrogen being in the back. The electron domain geometry considers a lone pair of electrons as it would as a bonding atom. Therefore, we consider it to have 1, 2, 3, 4 bond sides. You should memorize the bond names according to the shape of the molecule. So this one would be tetrahedral. However, the molecular geometry considers a lone pair of electrons, giving us the shape of trigonal pyramidal. In a tetrahedral, the distance between each atom is 109.5. However, these lone pair of electrons have a greater repulsion than the atoms, forcing all the atoms to be pushed down, making the angle even smaller. In the IB, you can say that the angle between the bonds is less than 109.5. However, you can give values below this, and you can consider each lone pair of electrons to be minus 2.5 degrees from the original structure, which gives us approximately 107 degrees.